absolute value functions have some common characteristics, which we'll have a look at. But the first thing you were to do was just complete a table of values and sketch a graph, right? And when you did that, what did this graph look like? Like a V? Yeah. Where would the vertex of that V be?
At 0.
No, I don't think it was at 0, was it? It was at 3. 3, 0, right. So it looked like this. Let me see. It should have looked something like this. A V shape, which is basically linear, right? And it's kind of two parts of linear functions. So one linear function on the left over here, and a different linear function over here. And that's what absolute value does when you do the absolute value of a function, is it splits it into two or more parts. Well, two parts really, but you'll see how that works. And that you could get, this graph you could get either by graphing on your calculator or by filling in that table of values and graphing it. What would you say the domain of that function is? All real numbers, that's what that means, right? The domain is x such that x is an element of the set of real numbers, which means x can be anything. What about the range of this one? Y is greater than or equal to 0. We could have done those also. That's set notation, right? Does anybody know what they would be in interval notation? Negative infinity to infinity for the domain. Round brackets. What about the range?
0 to infinity.
Yeah, hard bracket, 0, infinity, soft bracket, right? Hard bracket because the 0 is included. Okay, so that's something that you'll need to be able to do, is state the domain and range. And we looked at that when we did quadratic functions as well. And the other thing we have to do with an absolute value function is write a piecewise function. A piecewise function it's a function that's broken into multiple pieces. And it's a way to write an absolute value function without using the absolute value signs. And this is really the only time in high school that you see piecewise functions, unless you take calculus. And when you take calculus, it's really important that you can write a piecewise function. So that's what we're going to spend most of our time on today, is figuring out how to write the piecewise function. What we need to do to write a piecewise function is figure out the equation of just this piece of the function. You can see where it switches from one to another, right? It's at that vertex. It's here. So to the left of that red line is one function and to the right is another. And both of those, you should be able to tell me what the function is. So let's look at the one on the left. If it didn't switch at that red line, what would that function on the left be? What would the equation of it be? That function on the left is y equals negative x plus 3. I'm actually going to do something like this. Plus 3 because it crosses the y-axis at 3, and negative because the slope is down 1 to the right 1. So negative x plus 3. But what we need to write is for the absolute value function that we have graphed there. So now looking at the whole thing, for what parts of it is it equal to negative x plus 3? And it's equal to negative x plus 3 on the left. But we want to say that in terms of x. We're going to say when x is less than 3. or we'll say less than or equal to. If x is less than or equal to 3, then the function is negative x plus 3. What's the other piece of it? This part over here on the right. What's the equation of that line if it were just to continue? Y equals x minus 3, right. And it's x minus 3 if x is greater than 3. So let's do the same thing with this one. I think this is the second one that was on your sheet, negative 2 absolute value of x plus 1. When you graph this one, you get an inverted, an upside down V with its vertex at 0, 1. So domain and range again? What's the domain of that? All real numbers? Yep. So I'm going to just say negative infinity to infinity. And the range? Negative infinity to 1, yeah. You need to put the lower limit then the upper limit, so negative infinity to 1. Or you could say y is less than or equal to 1. So there's the domain and range. Then we need to write the piecewise function. So we need to look at the two sides of it. And I'm going to do this one kind of more systematically than we did the last one. Because I think I know what the pieces are just by looking at the equation. Well, we'll try it. Y equals. I think one piece is going to be negative x plus 1. Because that's just basically getting rid of the absolute value sign. So that should be one piece of it. Basically the positive part of the absolute value. The negative part of the absolute value is going to be, I'm just going to do it off to the side here. I need to think about this. Negative 2. We change what's inside the absolute value to negative, but the stuff that's outside stays the same. So negative 2, negative x plus 1, which actually simplifies to 2x plus 1. I think those are the two pieces. So if I wanted to graph negative 2x plus 1, I would start at 1, and then I have a slope of negative 2, which means down 2 over 1. That's this side, right? Negative 2x plus 1. Mm-hmm. So then I would say it's equal to negative 2x plus 1 when x is greater than or equal to
1.
Not 1, the x value we're looking for. 1 is the y value. 0, yeah. Right? This point here is at 0, 1. So the x value is 0. Right? We have to list it in terms of the x value. So then does the other one make sense? 2x plus 1. So I'll go to 1 and then up 2 over 1. Does that look like this line here? Yeah. If we were to continue that, up 2 over 1. So that's going to be when x is less than 0. So what are the two parts? Let's see. Y equals, remember 1 is just x squared minus 4. It's just get rid of the absolute value signs. I'm going to move that. I'm going to write it down here instead so that we have more room. X squared minus 4 is one piece. What's the other piece?
Negative x squared.
Plus 4. Negative x squared plus 4. So you have to change the signs of everything that's inside the absolute value sign. Don't change anything that's outside the absolute value sign, but this one doesn't have anything outside anyway. But change the signs of everything. So it's negative x squared plus 4. And then we have to see when is it x squared minus 4 and when is it negative x squared plus 4. We think about what we know about quadratic functions. X squared minus 4 is going to have its vertex at 0, negative 4. So it's going to look like this. It's going to go here and up. And here and up on the other side. So it's the outside parts here and here that are the same as x squared minus 4. Which means it's when x is less than negative 2 or x is greater than 2. So I'm just gonna write that like that. X is, so it's x squared minus 4 when x is less than or equal to negative 2, or x is greater than or equal to 2. And then it's the negative x squared plus 4. That one has its vertex at 0, 4 and opens down. So that's this part of it, the inside part. And this function is equal to that inside part when x is between negative 2 and 2. Which we can write that in one statement. Negative 2 is less than x. We'll just do less than. Is less than 2. Negative 2 is less than x is less than 2 means x is between negative 2 and 2.